do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Vector resolution. Very simple and easy topic for me. It can also become very simple and easy for you if you do two things. Number one, close your notebooks and put your pen and notebook aside. Number two, or the second thing to do is listen carefully to every single word that comes out of my mouth. I'm repeating. This topic can also become very easy for you if you do two things. Number one, close your notebooks and put your pen and notebook aside. Number two, listen carefully to every single word that comes out of my mouth. Then this topic will become super easy in next 20 to 25 minutes. Let's begin with this diagram. In this diagram, we have a vector A making an angle theta with x-axis with horizontal. Consider a vector A making an angle theta with x-axis or with horizontal or x-axis. The topic is vector resolution. Look here. If we move along the x-axis, this is x-axis, along the x-axis about 5 meters, then along y-axis and about 7 meters along y-axis. Then we will reach to the head of this vector A. To reach at the head of this vector A, first we will move along x-axis 5 meters, then along y-axis about 7 meters. This is AY, vertical component. The component of vector A along y-axis is AY. And this is AX. Component along x-axis is AX and the component along y-axis is AY. This is vector resolution. The topic is vector resolution. What is vector resolution? This is vector resolution. Dividing a vector into its components. Splitting a vector into its components is called vector resolution. Breaking, we have broken this vector A into its components. Breaking a vector into its components is called vector resolution. Or splitting, breaking, dividing, they have same meaning almost. Splitting a vector into its components, AX from here to here, AY from here to here. Splitting a vector into its components is known as vector resolution. Look at the definition. Splitting a vector into its components is called vector resolution. Splitting a vector into its components, AX and AY is the component of this vector. Splitting a vector into its components. Splitting a vector into its components is called vector resolution. Usually x and y components. Here we divide it into x and y components. Now, this vector A has x component and y component. Vector A has x component and y component. This plus sign is because of the head to tail rule. According to head to tail rule, This is the resultant of these two components. That's why the plus comes here. Now, one important thing to remember here, if you use arrows, then don't write I and J. If you don't use arrows, then write I and J. I and J are the unit vectors that specifies the direction. I specifies the direction along x-axis and J specify the direction along y-axis and K along z-axis. So I, J are the unit vectors, AX and AY are the magnitude. AX is here about 5 meters, AX is 5. I shows the direction along x-axis. AY is the 7. AY is 7 and J is the direction along y-axis. So remember that if you use arrows, don't write I and J. If you don't use arrows, write I and J. Now, in 2D, a vector is resolved into x component and y component. What's the difference between 2D and 3D? Look here. This vector A is in 2D. This vector A is in 2D. And this vector is in 3D. What's the difference between 2D and 3D? In 2D, we have two axes, x-axis and y-axis. In 3D, we have three axes. In 3D, we have three axes, x-axis, y-axis and z. Z is in this direction, perpendicular to the both x and y. Z is in this direction. So in 3D, we have three axes, x-axis, y-axis and z-axis. So in 2D, we have to move in first in x and then second in y. And in 3D, this vector is in 3D. This vector. In 3D, first we will move along x-axis, then along y-axis, and then along z-axis. Z-axis is in this direction. So this is in 3D. We can't draw 3D on board or notebook, but we can draw 2D diagram on board or a paper. Hope you got the difference between 2D and 3D. Two-dimensional or three-dimensional. This is three-dimensional. First dimension along x, second along y, and third dimension along z. And this is in two-dimensional. First along x, second along y. Now, in 2D, two-dimensional, a vector is resolved into x component and y component. X component in 2D, a vector is resolved into x component and y component. X component is also known as horizontal component or the projection on x-axis. X component is also known as horizontal component or the projection of vector on x-axis. What is the projection on x-axis? I'm explaining. Wait. And y component. Y component is also known as vertical component or projection on y-axis. Look here. What is the projection on x-axis? Look here. I'm trying to explain the projection on x-axis. This is along y-axis and this is along x-axis. This is y-axis, this is x-axis and the vector A. This marker shows the direction of vector A. This marker shows the direction of vector A. This projection means shadow. If I place the light on this side, the projection of this vector falls on y-axis. This is known as projection of vector on y-axis. And if I place the light on this side, the projection falls on the x-axis. This is known as projection on x-axis. This is the projection of vector on x-axis and the projection of vector on y-axis. Now, rectangular components. What are the rectangular components of a vector? Ax and Ay are the rectangular components of a vector. Ax and Ay, they have an angle of 90 degree. They are perpendicular. Angle of 90 degree. They are perpendicular. Ax and Ay are the perpendicular. Ax and Ay are perpendicular means they have an angle of 90 degree. Perpendicular means they both have an angle of 90 degree between them. So they are the rectangular components of this vector. This Ax and Ay are the rectangular components of this vector. Rectangular components. The components of a vector which are mutually perpendicular. They both are perpendicular. The components of a vector which are mutually perpendicular are known as rectangular components, are called rectangular components. Now, for example, x component, y component, sometime z component. And here I already explained up to here. Now, I and j are the unit vectors. I shows along positive x-axis and j I is along positive x-axis, j is along positive y-axis. Unit vector. A unit vector specifies direction and has a magnitude of 1. This unit vector I and j specifies direction and has a magnitude of 1. Now, finding magnitude of rectangular components. Rectangular components means Ax and Ay. Here we have to find the magnitude of Ax and Ay. This is the magnitude of Ax and this is the magnitude of Ay. Let's see how to find. Now look here. This is the origin O. This is our origin O. Let's call this point P, OP and this point Q. OPQ. OPQ. This is the triangle. Now we have a triangle OPQ. Triangle. For the magnitude of Ax and Ay from right angle triangle. Do you know this statement? Some people have curly brown hair through proper brushes. Do you know this statement? Some people have sin theta is equal to perpendicular over hypotenuse. Sin theta is equal to perpendicular over hypotenuse. Curly brown hair, cos theta is equal to base over hypotenuse. Cos theta is equal to base over hypotenuse through proper brushes. Tan theta is equal to perpendicular over base. Now, sin theta is equal to perpendicular over hypotenuse. Now look here. In front of theta, there is always perpendicular. This is perpendicular. This is the base and this is the hypotenuse. Remember this. In front of theta, there is always perpendicular. This is base and this is hypotenuse. Now, sin theta is equal to perpendicular over hypotenuse. Perpendicular is AY, so P is replaced with AY. Hypotenuse is A, so hypotenuse is replaced with A. Sin theta as it is. A is dividing here. On the other side, it will be multiplied. AY is equal to A sin theta. AY is equal to A sin theta. This is the magnitude of AY. magnitude of rectangular component, this rectangular component. Now we have to find the magnitude of this rectangular component. Cos theta. Cos theta is equal to base over hypotenuse. Base. Base is ax. Base is replaced with ax. Hypotenuse. Hypotenuse is a. Hypotenuse is replaced with a. Now cos theta as it is. A is dividing. On the other side, it will multiply with cos theta. Ax as it is. Ax is equal to a cos theta. Ax is equal to a cos theta. The magnitude of rectangular components. So we found the magnitude of rectangular components. Now look here. Finding a vector from its components. They both are opposite to each other. Here we have to find a vector. We have to find the vector. Vector A and its angle theta. This is the vector A and this is angle theta. But here we have to find AY and AX. AY and AX. But here we have to find A and theta. This A and theta. They both are opposite to each other. Let's see. If AX and AY are given, then by applying Pythagoras theorem on triangle OPQ, on triangle OPQ, in this triangle, by applying Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. This is Pythagoras theorem. Hypotenuse square is equal to base square plus perpendicular square. Hypotenuse is A, so H is replaced with A, square as it is, equal to as it is. Base is AX, so base is replaced with AX, square as it is, plus as it is P. P is AY, P is replaced with AY, square as it is. Now taking square root on both sides, square and square root will cancel out. A is left here. This is the magnitude of vector A. We have to find a vector. This is the vector A, magnitude of vector A. If AX and AY are given, if AX and AY are given, by putting the value we can find the magnitude of vector A. Now for the direction. For direction of vector A, we have to find the angle theta. Let me explain this. Theta tells us the direction. How it tells us the direction? For smaller theta, the direction will be like this. Their theta is smaller. The direction is like this. And for greater theta, the direction will be like this. So for direction, we have to find the angle theta. So for direction, tan theta is equal to base over perpendicular over base. Tan theta is equal to perpendicular over base. Perpendicular is AY. Perpendicular is replaced with AY. Base is AX. So B is replaced with AX. Now tan theta when comes to this side, it will be tan inverse. Theta is equal to tan inverse AY over AX. If AX and AY are given, then by putting the values we can find the value of theta or the direction of this vector A. I am repeating, this and this, they both are opposite to each other. Here we have to find the vector and theta, means we have to find this vector and theta. But here we have to find the magnitude of rectangular components. Here we have to find AX and AY. AX and AY here, AX and AY here. But here we have to find A and theta, they both are opposite. Now position vector. I'll try to explain position vector with an example. Let me explain this. We have a point here. What is the position vector? Position vector is the vector from origin and the coordinate of this point. The coordinates of this point, the x coordinate is almost 5 and the y coordinate is 4. The x coordinate is 5 and the y coordinate is 4. 5 or 4. Now this is our point. What is position vector? A vector from origin to this point. This is position vector. Position vector, this is position vector. Position vector tells us the location of a point with respect to origin. The location of a point with respect to origin. This is the origin. Position vector, this is position vector. Position vector tells or specifies the location of a point with respect to origin. A vector that specifies the location of a point with respect to origin is called position vector. Hope you got this. Now, a general name for the position vector is A and B. A and B, a general name, means here A is 5 and B is 4 in this case. Now, look here. To reach at the head of this vector, first I will move along x-axis 5 meters or A. This is A. And then 4 meters along y-axis. 4 meters along y, and 4 is B. Now this vector has two components, A and B. R has component A and B, R has component A and B. I shows direction along x-axis and J shows direction along y-axis. So position vector R is equal to AI plus BJ. And for magnitude, by applying Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. After taking square root, we will get the magnitude R is equal to under root A square plus B square.